the TV304 floating suspension turbomolecular pump. This is one robust pump.
This is Paul Russell here from the Santa Clara site at Agilent Technologies, and I wanted to speak to you today about one of our programs here with the TV304 turbo pump incorporated into our Tonga mass spec platform. This program is very significant because this is one of our highest selling mass specs, and it was very significant that we had a very high reliability end result of our products as we integrate all the components. My role in this activity is to work with these teams, and I was very pleased to work with many professionals worldwide to develop this program and make sure we went through all the rigid testing requirements that Agilent has in place in order to ensure that quality and the high reliability customers expect from us.
Hello, and welcome to Santa Clara, California, Corporate Agilent. We're currently in the sales and demo lab for Vacuum Products Division, and I had the great opportunity today to introduce the TV304 floating suspension turbomolecular pump. This pump was designed with feedback from the field applications team, the sales team, the marketing team, and all that information was driven by our customers and their particular needs. Working in conjunction with Torino, Italy, the Torino team did a great job in the development of this product. Here in Santa Clara, though, I also got to be interfacing with the quality engineering team here in-house.
Hi, this is Kevin Draper. I am the project manager for the 5977 MSD mass spectrometer. This is the world-leading mass spectrometer. Because of that, our customers have a lot of very high requirements and demands. One of them is reliability, the other is performance. The TV304FS really contributes to that value proposition to our customer. The reliability has proven to be outstanding. This is critical for those customers of ours who are running the instrument 24/7 and really need the robustness of the product to always perform and always be operational for them. The other is performance. Light gas, pumping speed is really critical for many of the applications. Helium and hydrogen are the most common carrier gases, and the TV304 has shown to be a very good pump for those applications in our application testing. I'm sure our customers will see the same when they get it into their labs. The third area, the last area, is the integration of the pump into the system. We work very closely with our partners in VPD and designed a really great integrated system that fits perfectly into not only into the box, but allows us to take advantage of the high reliability pump as it integrates into the system, as well as the high performance pump. So again, a perfect fit for our MSD and for our MSD customers.
We dropped this pump. We operationally ran this pump up to 56K RPM and dropped it in a piece of equipment and could not get this pump to crash.
Drop.
25 drops.
235 Gs.
235?
235 Gs.
We environmentally tested this pump. We drove up the temperature, we drove down the temperature.
So this is one of our chambers we use for temperature and humidity testing. And in this particular chamber here, we can ramp between -40 up to +70 to make sure the product is going to withstand all the rigors we're going to throw at it. During our TV304 development, we tested between 10 and 40 degrees C because we're outside the limits a little bit of our customers. But it gives us some assurance we've got margin in the product. And while we're measuring the actual temperatures of the bearings, etc., we're measuring the product itself to make sure it's surviving, and the Tonga which the product goes in, make sure the product is working all well as well when we're testing it.
We environmentally tested it for humidity, elevation, sound.
Okay, so this is our acoustic chamber, and basically in this chamber we put a product in the center of the room here and measure two aspects of sound. We do both the sound pressure and sound power. Sound pressure is what the customer is seeing off the face of the product, and what he's doing is trying to understand how much noise he's hearing. Sound power is what emanates through the whole room, and that kind of is what fills the laboratory up when we're trying to see how loud our product is. This is our EMC RFI chamber, which stands for electromagnetic compatibility or radio frequency interference. And this chamber is basically to test the electromagnetic spray that's coming off our product. Any digital device we produce today gives a signal to the air, and we want to make sure that doesn't interfere with the operation of other products. Likewise, we also do testing where we use this antenna as putting a field onto the product so that if there's other interferences coming from other products, It doesn't degrade the performance of our own product.
Vibration, and after each and every one of these tests, we check the integrity of the pump. When we were all done and said with that, we put it into its packaging. We then shook it up. We beat up the packaging itself, retested the pump again. This is one robust pump.
So this is our shock table, and we do various kinds of shock to our product to make sure that it can withstand the impact during transportation or normal use. Many times the customer will drop the product while he's installing it, drop the product during his shipping mode. We want to make sure that the product hangs in there and is tough enough to take that. This is one of the major tools we use in developing the FS 304 program. Over here is what we call a vibration system here, and this basically can, again, take a bare product while it's operating, while it's not operating, and perform testing on it. And this again simulates mainly transportation issues, because a lot of our abuse from our product comes in getting to the customer's site, not necessarily during the use of the product.
And my 23 years of experience in the field, I am guaranteeing that this pump will hit the ground running.